Hey everybody! Today we're going to be building one of our PIC18F14K50 USB plated through-hole development boards. Now this board here comes as a bag of parts kit. So in that bag you're going to get, of course, the circuit board. You have the resistors that you need. There's 6 of those. There are 4 capacitors, ceramic type. You get 2 LEDs, 12 megahertz crystal. Of course, you get a USB connector. There is a PIC18F14K50 IC in the kit, and that's actually been pre-flashed with Microchip's stock USB HID bootloader, so you'll be able to program this board without having, say, a Picket or other type of in-circuit programmer. It comes with an IC socket and 2 tactile switches, so everything you need to build the board. Other than that, of course, you're going to need some type of soldering iron, solder. I like to use little cutters such as these to trim off the leads once they've been soldered onto the board from the parts. Other than that, we're pretty much ready to go. So I'm going to start by opening up the bag here. We'll get our board out. There we go. And I'm going to open up the bottom compartment of parts. Let them all be free. Alright, so let's make sure we got everything we need first. There's our 12 megahertz crystal, our 2 LEDs, our 4 capacitors. And if you look at these, do have markings on them, and those markings are going to come in to play a little bit later. The larger one here is marked 474 on one side, and that's our 0.47 microfarad capacitor. I'll put that off to one side. We have another one here, which is marked 104. This is our 0.1 microfarad cap. I'll put that over here. And the last 2 should be marked 220. And those are going to be our 22 picofarad capacitors. Those are actually used in conjunction with the crystal for the oscillator. Alright, so we're looking good there. The resistors, you'll have 6 of those. You're going to have 2 which are 470 ohms. And the color codes on those are going to be yellow, violet, and brown. You're going to have 2 1K resistor. Color codes in those are going to be brown, black, red. Finally, you should have 2 10K resistors. And those are going to be brown, black, orange. Alright, looks like I'm good to go there. Alright, so the first thing I'm going to do is I'm going to solder in the LEDs that are used, the resistors that are used for the LEDs. So those are R5 and R6. You'll notice when I'm building my boards, I usually like to go in the order of smallest to largest component. That way the bigger components aren't getting in the way when I'm trying to solder in the smaller ones. So I'll just take this resistor here. I'm going to bend one of the leads straight over, which will give us something like that. I'll do the same to the other one. There we go. And now these are ready to go on the board. So again, these are going to go in R5 and R6. Go straight through the holes there. You'll see one side has markings for the body of the resistor. That's going to be the side with the hole. Resistors aren't polarity sensitive, so they could go either way, but for aesthetics I like to keep it this way. And there we have it. Alright, so now we can go ahead and solder those 2 resistors. So we'll flip the board over. Some people like to use those little bench top devices with the alligator clips to hold the board in place when they're soldering. I've never really used one, and I find that I can get by pretty well just flipping the board over and being careful. But they might be worth a try. There's one. And the technique I usually use when I'm soldering, kind of a multi-step process. When it comes to soldering, a couple key steps, or key goals. You definitely want to take your time, don't rush it. What I'll usually do is I'll start by applying some heat to the hole I want to solder here. I'll then bring in just a little bit of solder so the flux core can kind of wet the joint, help clean it up a little bit, and then I'll come back with a little bit more solder to finish everything up. And of course you don't want to go too slow. Extra heat's not usually a good thing. There we go. You also notice on my soldering station back here I have a wet sponge. Whenever I'm done soldering a section, I usually come over, clean off the tip of the iron. Also very critical. Alright, now that we have those soldered, we can go ahead and trim the excess leads off of that. Alright, now it's looking pretty good. You notice they stay in place pretty good. If you want to bend them a little bit to get them to stand up nice and straight, you could do that. Just don't go too far. You don't want to break the resistor. Alright. The next ones that I'm going to solder in are the 1K. Now the 1K resistors are these two outside spots, R2 and R4. And again, the 1K was our brown, black, red. And just like before, I'm going to bend them over. And you probably notice the resistors in this kit, and in general, have more than those three stripes. Like for example, this 1K resistor is actually brown, black, red, gold, and that fourth stripe represents the tolerance of the resistor. And if memory serves, gold should indicate that these are about 5% tolerance. Alright, we'll solder these. And if you're experienced with soldering, the total assembly time on this kit is probably about 20 to 30 minutes. If you're newer, you can expect to spend anywhere from 45 minutes to maybe an hour and 15 minutes. Again, key is not to rush. It's a pretty simple kit, not a whole lot of components to solder onto the board, so it goes together pretty quickly. Alright, now for those 10K ohm resistors. Brown, black, orange. Same deal. Fold them over. And these are our last two resistors. They're going to be R1 and R3. You notice I like to bend the leads just a little bit once I insert the component. It helps them from falling out of the board. Looking good. Excellent. As far as your soldering iron is concerned, I mean, you don't need anything super special. If you have a choice, I like a small round tip on the iron. Works pretty good for these kits. Chisel tip would work okay as well, if that's what you have. Alright, well, let's move on to the LEDs. Alright, now, LEDs, these are going to be sensitive to polarity or orientation. So when you put these into the board, you want to make sure you put them in the right way. If you look at the LED, see if you can focus there. Yep. You notice one of the leads is longer than the other. This is important. As far as the board here is concerned, you just want to make sure that that longer lead is facing the bottom of the board, and the shorter lead towards the top. Same thing with both of those, LED 1 and LED 2. As long as you do that, they will work fine. And if you happen to put the LEDs in backwards, well, they're not going to light up for you. In which case, you have to remove them, flip them around or replace them, and solder them back in place. Definitely easier to do right the first time. And we can bend the tops of the LEDs just a touch to get them to stand up nice and straight. Alright, we're looking pretty good so far. Alright, next up, let's solder in the capacitors. So we had those two 22 picofarad capacitors. We're going to go ahead and solder those in first. Now those are the ones that are marked with 220 on one side. You'll notice numbers on the other side. You just want to look for 220. You're not going to see that on any of the other caps. Now the 22 picofarad capacitors, these are the ones for the crystal, and they're actually going to be the top two spots on the board, C1 and C2. Again, the 22 picofarad caps, mark 220, go into C1 and C2. If there's any doubt, you can always download the schematic for this board, which is available on our store, where you can also purchase the board. And I'm going to go ahead and solder those in. So what would happen if you mixed up the 22 picofarad and the 0.1 microfarads? Well, quite simply, the board wouldn't work. So when you're done, if you go to power it up and nothing happens, it's probably one of the first things you want to check. Just make sure you got those right capacitors in the right spots. Alright. Now for the 0.47 microfarad cap. Happens to be the bigger one out of all of them. It's also the one marked 474. It's going to go on the lower right side here in the spot marked C4. And our 0.1 microfarad capacitor, which has 104 on it, it's going to go into the spot marked C3 on the left side of the board, bottom left. Flip these over, fan them out a little bit, and away we go. Looking good. And one of the reasons when you're soldering, you don't want to rush along, and you want to make sure that you're getting the solder joint warm enough. You want to make sure you don't get what's called a cold solder joint. Basically, what happens there is the solder doesn't have an opportunity to melt properly, and you could end up with a connection that's not solid. So you could have an intermittent kind of operation where maybe your circuit works sometimes and doesn't other times, or maybe it just flat out wouldn't work. When soldered properly, let's see if I can get this to focus for us, each of your connections should look nice and shiny and smooth. That's the best way I can describe it. Okay. Alright, next up, let's go ahead and let's solder that crystal in there. This one's pretty easy. It's not orientation specific, so you can put it in either way. I usually like to put it into the lettering. It's right side up, but let's just being picky. Go ahead and solder that. Trim those leads. Looking good. Alright, I think we're ready to open up the rest of this bag. Free the rest of these components. Throw that in my appropriately marked trash bin. Alright. Well, so here's that IC, the PIC18F14K50. Again, this one's been pre-flashed with that bootloader. If you want to grab the hex file for that, it's actually included in Microchip's Microchip Application Library download. If you go to www.microchip.com/MAL, you'll find the download file there, and it's in the folder marked USB HID bootloaders. We have our IC socket. I like using these sockets because it allows me to solder this to the board and not worry about soldering the chip directly. You know, if we were to do that, could get a little bit more heat than we'd want to get on the chip, which could damage it. Plus, with the socket, it's nice and easy to pop the chip out and replace it if we happen to damage the chip. Or, after programming the chip, maybe we want to move this over to another circuit that we've built. And we have our two tactile switches. All this just pops right out. Be careful not to bend the leads on that IC by accident. Alright, so next we're going to go ahead and put the tactile switches in the board. These are not direction specific, they can go on either way. The one tip I would have for you on here is make sure you're not holding the back of the board with your finger, because the backs of these are kind of sharp and you might just poke yourself. So keep your fingers off to the side. There we go. And those are bent nicely, so once they're in, they kind of snap in place. But we do want to still solder them, which I will do now. Alright, looking good. We're getting there, almost done. Next up, we're going to solder in the IC socket. If you look at the top of the socket, it's got a little indentation. That's usually used to indicate pin 1 on the upper left. So I'm going to insert that into the board here, facing upwards, so it matches the indentation on the board. That should push pretty easily into the board. These are kind of pre-bent as well, so they hold in place to make it easier to solder. Now when soldering these, what I usually do is solder down pad on one end, get that good and down, and then I'll go to the opposite corner on the other side, and I'll solder that down. That way I know this isn't going to be accidentally pushed out of the board. And I'll alternate to the other corners. And we can finish it up, get the rest of the pads. Definitely want to make sure you don't miss any of these. Almost done with one side, then we'll flip over to the other side. Again, just be careful not to rush. The gold finish on these boards definitely makes the solder flow nice and easily. Really a piece of cake to solder. Alright, make sure that all of them look like they have some sufficient solder. A couple I want to just go back and touch up just a little bit. Again, it should all be nice and shiny. Alright. Alright, time for the USB connector. Of course, going to go on the top of the board here. This one's pretty easy to insert. It's got two little holding clips which will kind of hold it in place. It does sit a little bit loose, so when I go to solder this, I'm going to show you a quick little trick. I use that foam that I had before, that came with the kit, to prop up one side of the board. Now, be very careful. I'm going to come in, and I'm going to start to put a little bit of solder on one of these holes here, and I'm going to hold the board down to the connector while it's still warm. Now, when I remove the soldering iron, the solder cools, it's actually going to hold that connector in place. And because I was holding it straight on the board, it's now aligned perfectly. Just want to be careful not to burn yourself, of course. These soldering irons are remarkably hot. And for the outer pins here, these are really to hold it in place. You don't need a ton of solder on those, just enough to solder the pins to the holes here. But if you want to fill it up with solder, you could do that too. Just make sure you use enough heat to fully melt that solder. Quick inspection. That is looking pretty good. Alright, our board is soldered. Last thing we want to do here before we power it up is go ahead and insert that IC. Now, you notice, if I can get this to focus for us, the leads in the IC are bent outwards just a little bit. So if we try to put this into the socket straight away, it's a little bit too wide to fit nicely. So what I usually like to do is put the IC down on a flat surface with one row of pins down, and ever so gently lead it forward. Flip it over, and do the same to the other side. Use a touch more on this side. So now if you look at it, more of a U shape. This is going to fit a lot more easily into that socket. Excuse me. Alright, so if we look at the chip, we see a marking on one side here. It's a little indentation, a little divot. That is indicating pin number 1. Also got a little dot of paint, something I add on there after I've flashed the bootloader to the chip, so I know that this chip has been programmed. I also put that usually by pin number 1, so either of those markings you want to have facing towards the top of the board, also towards that indentation that we left on the IC socket. Just want to align this. Really, the only thing to watch out for here is to make sure we're not accidentally bending any of these pins under or outside of the socket. Other than that, it goes in nice and easy. And there you have it. There is a completely finished PIC18F14K50 plated through hole USB development board. Ready to go on your latest project. Alright, well thanks for watching. Hope you had fun, and we'll catch you again next time. Thanks.